Welcome to surveying course. So this is lecture number 3, unit number 2. So if you recall last two lectures we have discussed about the introduction to surveying, like what is surveying and what are the basic objectives of surveying, why it is important for the civil engineers, and all these things we have discussed in details. And in the lecture number 2 we have discussed about different fundamentals of mapping, such as the scale. So scale is one of the very important parameters while drawing a map. So scale is nothing but the length of a line on a paper upon length of a line in actual field. So basically, we have discussed in different cases or to prepare different types of maps, we normally choose different types of scales as well. So now, if you want to draw the entire country border or country map, topographic map, where normally we show the hills, rivers, all these parameters. So in that case, basically, what we do is we take the smaller scale, and then we draw the entire plan or entire map. Whereas if you want to map a small area, small city, or maybe a small village or small region, in that case the scale will be very large, we can consider, and we can draw the map accordingly. So in this lecture number 3, today we'll be discussing the overview of surveying and the Indian topography map. So as you know, the basic objective of surveying is basically to prepare the map or the plan of an entire land. So in this lecture, basically we'll be seeing the how exactly on field surveying process goes step by step. So let's get started. So here the overview of land surveying. So the fundamental objective, as I mentioned earlier also, that is the land surveying is to prepare the plan or the map of an entire area. The map thus prepared serve as a primary source of information about the earth surface, right? So for the art surface, is not it? So what we'll do, this is a plan area, right? So we have the latitude longitude, you can see 71 degree latitude, 1 degree longitude, like 26 to 27. So the map thus prepared, basically this is map is prepared, basically this is the primary source for the information of this art surface, right? We want to show the important features on the earth surface, like some region there will be a river flowing, some region there will be a big hills are there. So all these things we have to demarcate it on a map. So that is our primary goal of surveying, basically to establish the primary objects on a earth surface. So now the data required for making such maps are basically collected from the field surveying, right? So basically data, whatever data, so for example you want to there may be a hill is there. So basically we go to site in this location and we find out how much is the length of the hill, or if it is a river, then what is the width of the river, from where it is starting, where it is taking the turn. All these things we note it down, we measure it in a when we go to real site, and then ultimately we draw it here. So basically we collect the data required for constructing this map through the field surveying. So now the next question is, now you understand our main objective is to basically to prepare the map. And to prepare the map we have to go to field, right? In the field we take so many measurement in the sense, what is the height, what is the length, where is the river, where is the valley, all these parameters we have to locate it, right? Now we have to go to start the field surveying. So when we go to site, or when you go to any field where you want to do the mapping, right, for this area, so there also you have to follow some systematic approach to measure the entire land. Because now you can see this is actually 1 degree, right? 1 degree means almost 100 kilometer, you can imagine. So this is 75 degree, 1 degree latitude, 1 degree longitude. So basically you can imagine in real side, this is basically 100 kilometer by almost 100 kilometer, 110 kilometer by 110 kilometer. So it's a huge area, you can imagine. So now we are basically a dot in this. When you go to a field, basically we are a dot in any point in a map. So what will happen is, now from this point, now we have to visualize, right, entire map we are drawing, right? So we have to follow some systematic approach to get the entire map area done. Okay, so to start the field surveying, it is required to know very accurately the geographical coordinate, latitude and longitude, for at least one point known as control points, right? And the length as well as the azimuth of a line, which is known as baseline. So what we have to do, so for example, we want to find out map of the entire region. So this is 1 degree means, as I mentioned, this 110 kilometer by 110 kilometer approximately. So it's a huge area. You can consider this is Hyderabad region, or maybe any city in India, or anywhere else in the world. So to draw the map of a region, so what we need is at least one control point. So what is control point? So control point means some point, as I mentioned in the last class also, where the latitude and longitude you know. So for these points, latitude and longitude we know. So that we call it control points. So at least one control point we need to have on an entire region. Control point means the latitude, longitude, right? What is the elevation, mean sea level from the from what is the height from the mean sea level? So all these parameters has to, we should know. Then only with reference to this point we will survey the entire land. Is not it? So these points basically we call it control points. So if we have more number of control points, minimum actually two control points are actually required on a so to prepare the map. So control point means where the coordinates we know. So this coordinates latitude longitude we know. So for example in this map basically this point, if you see, this is one control point. So this latitude and longitude of this point we know. Similarly this is also another control point. So these two control point we know, and this line connecting line between these two control point we call it baseline. So basically this baseline, we know what is the length of this baseline and what is the azimuth. Azimuth means basically how much angle it makes with the north, that we call it azimuth. So azimuth means how much angle it makes, right, with north. So if you see, this is the north direction, right? So in a map we have four directions. So this is our north direction, right? Then this is our east, this is south, and this is west, right? So this is our basic direction of a map. So from north direction, what angle it makes, this baseline, that basically we call it azimuth angle of any line. So this angle almost makes 90 degrees, right? So this so we know. So to start the field survey, what we have to do is at least we should know the two control points. So this control point, what is the latitude, longitude, what is the elevation, mean sea level we should know, and we should know these points, latitude, longitude. So first we'll go to site and we'll find it out this point, which is the control point we know basically, right? Latitude, longitude, and this one. So by connecting these two lines, basically we know this is the baseline. So baseline length also, distance also we know, we can measure it even field also by using tape or any any scale, long scale. Basically we can find it out what is the baseline length and what is the azimuth angle also. What is azimuth? Azimuth, as I mentioned, basically this is the how much angle it makes with the horizontal, that we call it azimuth. Okay, so now all these points are basically these 2 points are basically known in a field. So now once we know the latitude and longitude of a particular plan, basically how do you know these two control points, latitude, longitude? That also we know from the astronomical survey. So what is astronomical survey? Basically by looking into the objects, astronomical objects on the sky, basically we establish these control points, right? So by doing astronomical survey, basically we find it out what is the longitude and latitude, longitude of these control points. So and the length of the line is also, as I mentioned, this is also measured using the instrument. We have so many instruments to measure this baseline length also. So now from this control point in association with baseline, so we have what, we have these two control points known, as well as this baseline also we know. So from the control point in association with this baseline, a number of intervisible points are selected such that on joining those points, a well-shaped triangles are required to be formed. So what we do is with this, basically we take another point. So maybe in this area may not be plain, right? There may be some portion valleys, some portion big hills will be there, trees will be there. So we'll do, so from this point we will find it out some other point. So in this another point, this is another point we established with respect to this control point. So this point we have established such that there it is visible from this point and as well as from this point. Maybe there is obstruction in the middle, so we have to choose. Maybe there, let me take another color. So here maybe a small hill is there, for example. You can imagine it is a very small hill. So here maybe another something, lakes or something is there, right? This is a lake. So this point you have to choose such that from this point to this point it is visible. So intervisible points you have to choose from here to here or from here to here. So intervisible points we will take, because we will use some instrument, right, to locate this point. So the visibility should be good, right? There should not be any object, or there should not be any tree, or any big hills. Nothing should be there in middle, so that we can see this point from this point. So similarly, this point can also be visible from this point, right? So this point we have to choose such that this point should be visible from both the control points. So like that, multiple intervisible points you have to choose. So once this is our first point we choose, so this is basically one triangle we made. So this is one triangle image. So we know what is the latitude longitude of this point, we know what is the latitude longitude of this point. So from these 2 points, and we can find out what is the angle here and what is the distance also. So we know, once we know all these parameters, then we can find out what is the latitude and longitude of this point, right? So now we know additional information, this what is the latitude longitude of this point as well. So earlier at the beginning we only know the control point, means here one control point, here one control point, we know the latitude and longitude. So with these points basically we established one more point. Okay, so now we have to choose another point. So like that, in triangular fashion basically we entire plot area we basically will do it. So these whatever these triangles are carried forward, right? Carry forward points whose graphical coordinates are basically calculated from the measured horizontal distance and horizontal angles are taken from the network of triangles. What do we do? So with these points we establish this point. Now from here one more point we have to choose, but that point, make sure that this point should be visible from this point. It should be directly visible. There should not be any obstacle here. If there is any obstacle, then what will happen? So it is very difficult to establish this point, because there, so we have to sight it out, right? Something, we have some instrument, from there we have to look into this point. If there is any obstacle in the middle, then we can't see directly here, right? So in that case again we cannot establish this point. So we have to choose this point such that it should be visible from the control point. So we know what is the latitude and longitude of this point, and we know what is the latitude and longitude of this point. So now with these two reference point we will establish this point. Okay, so this is another triangle basically we are making. So like that we are basically constructing the point. So this is one point, so this is another point, like that another point here, like that. So entire Hyderabad or any city region, so 100 kilometer 100 kilometer, basically we are distributing it into a large big triangle. So that's why in surveying we call it, sometimes it is triangulation also. Surveying means basically from this triangle part, basically we divide the entire area into a small parts. So if you recall, in the last lecture we have discussed what is the principle of surveying. That is, we are working from whole to parts, right? That is our principle. What is whole to parts? So this is the entire whole area, right? 100 kilometer by 100 kilometer area. So from there basically we are dividing entire area into small parts, right? This triangle parts means we know what is the kilometer of all these triangular points, right? So from originally these two control points, from these two control points basically we established all other these triangular points, right? So that's why this is, we call it in surveying, our principle is, so from whole to part. So this is entire whole. From there basically we are making small parts, and from inside this part again we will do the surveying. Okay, so entire area now we are divided into small this triangular part. So the calculated parameters undergoes further adjustment by satisfying the geometrical condition associated with the parameters as well as with the figures. So what we do here, basically this is a triangular shape, right? So all these geometric shapes we are constructing, is not it? So we know the properties of geometry. So once we find it out the latitude and longitude of this point, now we can find it out even from geometry also, what could be this angle. Or once we know the angle, if we measure the angle, then we can find out what is the length of this line. So from this geometry also we can verify how much error we did in a practical site. So this is also advantage using this triangulation. Okay, because once we identify latitude and longitude of this point in a field, although we are using some instrument and it is a very big kilometer, you can imagine this to this may be a 30-40 kilometer long, so it is very long. So while measuring this distance there will be some errors definitely. So what we'll do, so once we identify what is altitude and longitude, now you plot it on a paper. So it makes a triangle. So you find it out through this angle, how much is this angle, and we find out what is this angle, we find out what is this angle. So once we know these three angle, we plot this triangle into the paper, and then using this triangular property you can easily find out what is the distance of this one, what is the distance of this one, what is the length of this one. Basically all these three lines length we can easily compute using our geometric equations and all, right? So now we know, once we know the length on as per our geometry length, then we can in field also we can find out what is the distance between these 2 points, right? So both, if both are matching, then we can understand that this whatever coordinates we have find it out latitude and longitude for this point, it is correct. But if there is huge difference or small difference, that is the error. So such that, so that's why this calculator, so this calculated parameter whatever we have calculated, that also can further be adjusted by satisfying the geometric conditions basically associated with this triangle, okay, with the figure. So like that we can, even if we make errors, we can basically rectify the errors. So basically this helps basically the minimization of errors which will occur in the during the survey. So now what will happen is, now these big triangles will be there, right? Already we find out these big triangles. So now these big triangles are also will have well separate, can be again further divided or further classified into again small points. So what we did at the beginning we know the latitude and longitude of only this point, control points. Now after this surveying, that is initial surveying, basically we know what is the latitude of this point, latitude longitude of this point, like that all these triangular points basically we know the latitude and longitude. So now inside this big triangle, so inside these big triangles formed by widely spaced control points, networks of small triangles get established. So once we know these big points, big triangles, big control points, this control point, this control point, now we go inside this triangle now. So that's why you can see from entire whole to parts we are going gradually. So entire area now we divided into these triangular shapes. Now from there, inside these big triangles, now we'll do surveying. So if you see this figure, so basically here we are doing, so this big triangle, so here if you see this is a big triangle, right? So inside this triangle now we come in a field now we are into inside this triangle, and again we divide, we establish such small points inside the big triangle. So this big triangle again, so there we choose one point. So with these points we have to choose such that this point, from this point and this control point should be visible, then only we can establish this point. So this point we cannot choose arbitrarily at any point, because maybe somewhere maybe hill is there, so in a hilltop we cannot take any point, because we may not sight or we cannot see from hilltop to this control point. Similarly, if there is any river or so, or a big lake, so in that case at the middle of the lake we cannot take it, we cannot go in the middle of the lake while taking the control points. So this point has to be chosen such that from this point basically we can cite at least minimum two control points, so that we can establish what is the latitude and longitude of the new control point. So these big triangles now also now has been divided into small triangles. So see, the entire big triangle also been divided into small triangles, you can see. So our main objective is basically mm, to to get the as many as this latitude longitude coordinate points of the entire area. So now this process, whatever I mentioned, this process will be further repeated, and and we'll make small surveying, small triangles. And so once we make from this big to, we made so many inside so many triangles, now each triangle will go inside, and again we subdivide each plot or each triangle into further small triangles. Thus I mentioned basically we are basically working from whole to parts. So thus the entire surveying area, it gets covered with the network of triangles. So entire survey area is now these small triangles will be covered. Okay. So now we entire area, now this is one plot, maybe we divide it into different plot numbers, okay, or different part numbers basically. So this is one part we can consider, this is another part two, plot twos and plot three, plot four, like the multiple plots we can make. So inside one plot again basically we can measure a small distances, right? Small that control points we can establish, and we can do entire area. So like that the process will continue. And from this entire area, so in a nutshell basically, again I am repeating, so this from this entire area basically we go big triangles. So inside big triangles again we make these small triangles. So again with the small triangles we take the area where we want to make. So inside this area also again we make establish small points, and again from there we locate the each object. So for example, this area we want to find it out, right? So we have a control point here. So now here you can see there is a big lake. So now from the with reference to this point basically we identify what is the lake starting point. So for example, here you have a lake. Now we established these 2 points. So this is one control point we established, and this is another control point we established, right? So with this control point, now we find it out what is the starting point of lake. So this point maybe we establish now with respect to this control point. Similarly, with respect to this control point, maybe we establish some point. So like that, what we do with this control point, so we find it out what is the periphery, or what is the different points of this lake. So once we know different coordinate, now we can easily draw this lake on a map, right? We know what is the latitude longitude of different points all along the lake, and that we can plot it on a map. So like that, we have to identify each object. So this is one plot. For example, you have a small hill here, so that hill also we can identify from this point to what is the foothill distance, or what is latitude longitude points. Like that, we can identify each object. That is our main objective, basically, to prepare the map, right? Map of a area. So that's how we do. Basically, we make small triangles and then we do it, right? So now you can see this is the plot one. As I mentioned, this is the entire area in the last slide which I have shown. So here now we divided into small, like plot 1, plot 2, plot 3, plot 4. So in the again from the plot 1 we establish this small this red color control points, right? So from this control points we establish the small control points, and from there basically we find out what is the distance from this point to a hill or a tree or whatever we want to survey, right? That is our objective. So if you want to make that topography map, that means basically we are identifying where we have the jungles, forests, where we have the lakes, where we have the hills. All these things basically we show in a topographic map, right? So this one you can see the details of surveying is then basically carried out within the smallest triangle. So what we do in the smallest triangle now, detail surveying means we are locating now the hills and the lakes, okay, all these things. So during the surveying, measurements like distance, directions, right, angles are important, are taken, right? So from this point, see here one lake is there, so this lake is shown here. So in this spot, so this lake is basically identified from these two control points, okay? So if here is if in a lake, then this lake will be identified from this point and this point, right? So these measurements are then used for the necessary calculations, and adjustment of results are identified for the finding of the position in a object, right? So now, so once in a field, basically we find it out, we take the measurements, and then we come to office, and then we prepare this type of maps on an office. So to prepare this type of maps, first we make this grid point. So you can see in the last lecture we have discussed, we basically make the rectangular grids. So see, like that, like 1 degree or 0.5 degree, or different small scale, we can divide the entire area into these grid points, and this grid point with corresponding latitude longitude, we plot it, and ultimately we draw the objects. Either it may be lakes, or whatever may be the physical object that we are now identifying on a map. So control points are actually in that, normally it is taken on a spherical coordinate, right? Because in a plot basically it is spherical coordinate, okay? So it's approximately appropriately, so we have to convert the units also. The objects are basically then classically represented, graphically represented like that, you can see. So for the topography map, we show that terrain as well as jungles or lakes, all these parameters. So this is plot 1, as I mentioned in the last slide. Now again, after we complete the plot 1, we'll go to plot 2. So in the plotter plane, so in this, from here now again we take small control points, these red control points we establish from these large control points, and from these small control points, again, if any object is there nearby, we locate it. How much is the distance we measured from this point? If you have a small or temple, or a big small temple is there, so how much distance is there from this point? We find out what is the distance, what is the angle, line angle, all these things, and then we plot it. So this plot is basically plot number 2. Here this area, we are showing it. So this plot is basically nothing but this one. So you can see different things we have located. We have located these hills, we have located these roads, all these parameters has been located nicely. So this is our like that, basically what we do is entire small part, as I mentioned in the last slide, we do surveying, and then ultimately we prepare the entire plot area for this region. So you can see this is the entire map of whatever I have shown here. So we divide it into small parts, right? And then from there we construct each portion, and then ultimately we combine the entire map, and we will get the entire topographic map of any area. So such that, like that, actually entire maps are constructed. Either it may be a political map, or it may be topographical map, or you want to show a road networks, whatever maps you want to make, such that basically this is the process of making any maps. So our main objective is to construct the map from the whole to part. So this is in a nutshell. Again, I am quickly explaining the entire area of surveying basically has been divided into small triangles, right, using this the two basic control points. These two basic control points are established for a city. For example, the survey of India, that is the government authority of Indian government authority for surveying, right? So they establish these control points all the city in all the cities in India. So like in Hyderabad we have some location where the latitude longitude, exact latitude longitude will be written, maybe small, they will make a small structure there where they will write, okay, at this point latitude and longitude. Maybe you can consider, I am giving example, maybe at the Hussein Sagar Buddha statue will be there, right? So at the center of this Buddha statue, maybe something will be written, okay, so latitude longitude of Buddha statue is this much. So this is our first control point. So with taking the reference of this Buddha statue, now nearby, if you want to locate the entire Hussein Sagar area or entire lake area, or nearby any gardens are there, right? Many gardens are there, so we want to locate this garden. So that can be done with reference to the Buddha statues, their known latitude and longitude. So, okay, so this entire area now we divide it into the multiple control points, and using this triangulation basically, right? Third point we establish using these two control points, and from this third point again we take the triangulation and one more points we establish. Like that, entire big area is divided into small parts. Then again we'll go inside this each triangle, and each triangle again we subdivide this triangle into small triangles. So now from this each smallest triangle basically we take the measurement, means where is the the statue, or where is the road, where is the park, all these things we identify what is the distance from this that control point. And ultimately we take all the measurements in a paper, when we are in a field, then we come to office, and then by looking into these measurements we prepare the entire map of the region. So now the Indian topographic map. So topographic map basically provides what? It's a graphical portrait of the object present on a earth surface, right? Means where we have the river, where we have lakes, hills, all these physical objects are there, right? So that we are showing it on a map, so that we call it topography map. So these maps are provided the preliminary information about the terrain, right? Terrain means basically the land, right? Whether it is flat or it is undulated. For example, you have to construct a road. So in that case, by looking into topography map of this region, basically you can understand in which area, which what could be the alignment of this road, right? If you how you can bypass the hill, because hill means again there will be ups, downs, or you have to make the big tunnels. So we can avoid all these things by looking into the plain land. So by looking into terrain or topography map, basically you can find it out all these parameters. This is very much important, and very much useful for the other engineering works as well. So for most part of the India, topography maps are available, which is prepared by the Survey of India. As I mentioned, Survey of India is a regulatory body for the Indian, for the India. So they are responsible to prepare these topographic maps of the entire region, entire Indian region. So to identify a map of particular area, a map numbering system has been adopted by the Survey of India. The system is so what will happen is, so to identify the topography maps of the different, so entire India, you can see this is entire India region. So topography map is prepared by Survey of India, and how they prepared, basically they use some numbering system, and using this numbering system the one topography map they have prepared. So an international series, like within 4° north to 40° north latitude and longitude, and 44° east to 124° east longitude, okay, at a scale of 1 is to 1 10 lakh, right, is being considered as a base map. So base map we prepare, so entire world map we have, right, entire globes we have. So entire world map we divide it into 4° north to 40°. So these grid points you can see, right, 4°. So this is Indian region basically we are talking. So 4° to 44° entire area we divide it into 4° interval. So this is the 4° line, and this is the 44° line, right? So entire area we divide it into 4° intervals. So 4, 8, 12, like that. This 4° grid point basically we make it. So from this 4°, again from this is the latitude, and longitude is this one. So longitude is from 44 to 124. So 44 degrees to 124 degrees. So this is the longitude. So this longitude also we divided 4 degree grid point. Basically we divide the entire area. Okay, so now each grid here you can this each grid is basically 4 degree by 4 degree. So 4 degree by 4 degree means almost 450 kilometer by 450 kilometer approximately. So you can imagine each grid here is basically 450 by 450 kilometer. So it's a huge. So what we make the we this is as per our Indian that survey of India, what they do entire area, entire nearby surrounding of India also what they did entire area they divided into 4 degree of rectangular square, and then give some nomenclature about it. So that we'll see in the next slide. So this in the last slide you have seen this small entire area, right? They made it into small grid points. So the entire topography area, so each grid point, so like this is 53, the next grid point is 54, like the number the entire grid point in this. So now each 53, so this is 4 degree, right? In last slide you have seen the entire one box is basically 4 degree by 4 degree area. So this is one box I have considered. So from this last slide just one box I have considered, and this is 28 to 32. So this is 4 degree, and this side also 76 to 80. So only one box I have considered. So that is numbering is 53, right? So each box will have some number 53, 54, 55, 56, like that. Numbers are there. So this block I have considered is 53 number block. So again there are some multiple subdivisions will be there for this 53 also. So now you can see the entire area how we divided into small parts, and then we prepared the map for each small portion. So for the Indian topographic map, each section is further, that is divided into 16 sections. So each section in earlier 4 degree 4 degree is further divided into 16 section. That is 1 degree 1 degree 1 degree. So it is total 4 degrees. So now 1 degree 1 degree 1 degree subdivision we do it. Okay. So now scale also will change accordingly. So now this 53 now again subdivided into 16 part, and A, B, C, D, E, F, G, H, like the nomenclature we give. So for this point, for this portion we call it 53N. Right, so this entire area we call it 53, and what is the area now here? It is 1 degree by 1 degree, right? 1 degree by 1 degree means 100 kilometer, or approximately 100 kilometer by 100 kilometer is the area here. So 53 is the entire block. So now 53 also we divided into 16 part, right? So each part will be basically 1 degree by 1 degree. So now again further, this each block also will be subdivided. You can see this 53. Now this is M, right? This M is again subdivided into 4 parts. So this portion is now total is half degree by half degree, right? This is also divided into 4 parts, and each section we name NW, means northwest, northeast, and southwest, southeast. So this each segment also now will be subdivided into these small parts. So now each point again we call it, this is the nomenclature to tell that. So this area, this portion, how will we call it? We call it 53 is this entire area, 53 M is this portion, and then SE means this portion, right? This portion you want to call it. Like that, again we classify the further thing. So further mapping is done here, you can see as I mentioned. So this is 4 degree by 4 degree, right? So again we divide it into 1 degree, A, B, C, D, we do it in the last slide we have seen. Now again this each block can be further classified into small 16 divisions. So again B is classified into 16 divisions. So each point, now this area, this length can be called 53 is 53 B, and third division. So this may be 53 B, fifth division. This entire area is called. Okay, so now again in further, each 5 can be classified into 4 different categories. So now it's here also you can see. So each block here again further classified into this that southeast, southwest, right? All these parameters, again 4 subdivisions can be done. So depending on the map, which map we want to produce, so see, we went from entire Indian map, how we actually further subdivide into small parts. So that is very much important. Okay, so this depends on basically which type of map we want to construct. If you want to construct a topography map, then in larger view we have to do it, but if you want to construct a small scale, then further we have to do it is for the small scale. So depending on our parameter, depending on our requirement, we further subdivide the entire plot area, and then from there, basically from this inside one's plot, basically now we'll start our surveying. So for example, if you want to construct the topography map of India, in that case maybe you can consider 50, this entire India map into this 4 kilometer or 4 kilometer grid point, right? From there we can make that drawing. Whereas if you want to construct the map of Hyderabad city or Delhi or Mumbai city, any cities, or in that case you can consider, further 53 can be divided into 16. So each part maybe one district of each region, maybe we can consider such that. So like that you can do. But now again you want to identify the villages in a district. So in that case further, each division also can be divided into 16 parts. Like that you can do it if you want to locate a village or on district. So depending on what we are locating or what is the purpose of drawing the map, we choose the scale approximately appropriately, and then we prepare the entire map. So what we have understood in this lecture is basically how exactly the field surveying is happening. So starting from big, so let me just quickly recapitulate what we have done. So one, we have the entire area. So our main object, and we know the control point. Control point means we know these 2 points, what is the latitude longitude. So from there we establish a third point. Okay, so we establish a third point, so which is visible from this point as well as this point. So once we find it out the latitude longitude of new point, this point. Okay, so this point once we know, so from this point and this point we further take another one more point here. So like that entire area we make it this small triangles we make. So in this triangle basically all the coordinates, all the points, this point basically is known, like we find out what is the latitude longitude. Okay, so all these things like the triangles we make. So from once we make the big triangle, so from there again we divide it into small triangles. Okay, like that we do it. So now inside the small triangle also again we make further small triangles, and from there basically we take the measurements, and ultimately we prepare the map of the entire region. Okay, so depending on the purpose of the map, we choose the appropriate scale, and then we prepare the maps. So that's all about this lecture. Thank you.